So in this video, I will discuss another system of naming coordinates called the polar coordinate system, the polar curves, and some polar equations. Okay, let's start with the polar coordinate system. Let us consider point O on the line OX, and we will call another point, say point P, not on the line OX, and a segment is drawn from point O to point P. And then we can now draw an angle theta, that's the angle XOP, to be our angle theta, with initial side OX and terminal side OP. And then the distance from O to P is what we call the radius vector R, and so P can be named R theta. So this system is what we call the polar coordinate system, where R is the radius vector and theta is the polar angle. And this angle theta, when measured in counterclockwise direction, is positive, and negative when measured in clockwise direction. And this is how a polar coordinate paper look like. It is characterized by polar angles from 0 to 360 degrees, or from 0 to 2 pi. And then the radius vector, that's 1 unit, 2 units, 3, and 4 units. And then the angles, 0, pi over 6, pi over 4, pi over 3, pi over 2, so on, until you reach 2 pi. Okay? Say we get this pi over 6 and 11 pi over 6 angle. When measured in clockwise direction, this 11 pi over 6 is the same as negative pi over 6. And pi over 6 is your negative 11 pi over 6. So we have, if this pi over 3 is your negative 5 pi over 3, and this 5 pi over 3 is your negative pi over 3. Similarly, your pi over 2 is your negative 3 pi over 2, and your 3 pi over 2 is the same as negative pi over 2. Okay. However, pi and negative pi will terminate on the same side, so as with 0 and negative 2 pi will terminate on the same side. Okay, how to plot points on the polar coordinate paper? Say we consider these points, and then we will be tracing it out on the polar coordinate paper. Say we got A, 3, 0. Remember, this is R, theta. R is the radius vector, theta is the polar angle. To plot points on the polar coordinate paper, so although the radius vector R is written first on the ordered pair, but to plot it out on the coordinate paper, we must look first for the angle. So that's 3, 0. We start at the origin. This is the pole or the origin. This is the polar axis, and this is the pi over 2, 3 pi over 2 axis. So you start at the origin always. So then you look for the angle 0. This is your angle 0. And then from the origin, you count 3 units. 1, 2, 3. So this is your point A. Next point B is 3 pi. So you look for the angle pi. So this is your angle pi. And then you count 3 units from the pole. 1, 2, 3, this is your point B. And then for point C, that's 2 pi over 3. So this is your pi over 3. And then from the pole, you count 2 units. 1, 2, this is your point C. And then for point D, notice that the radius vector R is negative. So this is negative 2 pi over 3. But again, you look first for the angle, that's pi over 3. This is pi over 3. But when the radius vector R is negative, you trace it on the opposite angle. You trace it on the opposite side. So this is pi over 3 extended over here for pi over 3, which means negative 2 pi over 3 is located 1, 2, and this is your point D. This is negative 2 pi over 3. Next, point E is 4 negative pi over 3. Again, this is your angle theta, negative. So to look for the angle theta, you do it in clockwise direction from this point going to this point. Okay, so this is what we're going to do. If you want to look for negative 2 pi over 3, you look for 2 pi over 3, and then locate its reflection over this line. And this angle is reflected over this line by the angle 4 pi over 3. Again, this is 2 pi over 3, and its reflection over this line is the angle 4 pi over 3, which means negative 2 pi over 3 is terminated at 4 pi over 3. So this is your negative 2 pi over 3. And then the radius vector is 4. So from the pole or the origin, you count 4 units. 1, 2, 3, 4. So this is where you can find your point E. For point F, both are negative. Negative 3 halves negative pi over 6. Again, this is negative pi over 6. You look for pi over 6. This is your pi over 6. And you reflect it over this line. So you will have a reflection here. So 11 pi over 6 is your negative pi over 6. However, the radius vector is negative. From 11 pi over 6 or negative pi over 6, you trace it on the opposite side. So it will be plotted against the 5 pi over 6 angle. So that's negative 3 halves. That's negative 1.5. So you can find your point F here. And then again, finally, point G, 7 halves pi over 2. 7 halves is 3.5. This is your pi over 2 or the 90 degrees angle. So you count 3.5 units away from the origin. So you got 1, 2, 3.5. And this is where you can find point G. Okay, so let us consider point C. Again, point C is located at 2 pi over 3. This point C can be named in 3 other ways. Okay, this point C can be called 2 negative 5 pi over 3. This is pi over 3, and this is 5 pi over 3. Okay, which means when measured in clockwise direction, pi over 3 is the same as negative 5 pi over 3. And then you count 2 units, 1, 2. So point C can also be named 2 negative 5 pi over 3. Another one is this point C can be named negative 2 4 pi over 3. If the radius vector is negative, okay, so which means this is your pi over 3, and it extended over this angle, that's 4 pi over 3. And if you set points on this angle and the radius vector is negative, you will draw it on its opposite angle. So when setting negative points on 4 pi over 3, you will plot it against pi over 3, and then you count 1, 2. So point C is negative 2, 4 pi over 3. And finally, you got negative 2 pi over 3. Okay, you look for negative 2 pi over 3. So 2 pi over 3 is located here, and its negative counterpart is at 4 pi over 3. Okay, so this is your negative 2 pi over 3. And the radius vector is negative, so you trace it on the opposite side. So you get 1, 2. So still point C. Okay. Next, let us consider point F. Point F is located at negative 3 halves negative pi over 6. Okay, negative 3 halves negative pi over 6. Again, this is your negative pi over 6. Yeah, this is negative pi over 6 or 11 pi over 6. So point F can be named 3 halves 5 pi over 6. Obviously, both are positive. 3 halves 0.5 pi over 6. It can also be named negative 3 halves 11 pi over 6. This is 11 pi over 6. Since 11 pi over 6 and negative pi over 6 are the same angle. And finally, point F can also be named 3 halves negative 7 pi over 6. This is 7 pi over 6, and its negative counterpart is 5 pi over 6. So 5 pi over 6 is the same as negative 7 pi over 6. 5 pi over 6 is the same as negative 7 pi over 6. And 11 pi over 6 is the same as negative pi over 6. Okay. Let us draw the relationship between the polar and the rectangular coordinate system. Okay. Again, we determine a radius vector OP. This is your angle theta, OX initial side, OP terminal side, and this is the radius vector R. So again, point P is named R theta, and then if we draw its relationship on the rectangular coordinate system, so you draw the distance from point P to the x-axis, that's y, and the distance of point P to the y-axis is x. And then you can now use the SOHCAHTOA principle. So again, the point P r theta is in polar coordinate system is represented the point P xy in the rectangular coordinate system. Okay, and then by Pythagorean principle, cosine theta is adjacent side over hypotenuse. So that's x over r. Sine theta is opposite over hypotenuse. And tangent theta is opposite over adjacent. And then from here, you can draw theta, which is equal to arc tangent y over x. And again, by Pythagorean principle, this is the hypotenuse, the opposite side, and the adjacent side. The square of the hypotenuse is equal to the sum of the squares of the two other sides. So you got r squared equals x squared plus y squared, or r equals plus minus, that's plus minus the square root of x squared plus y squared. Okay. Say we want to represent point negative square root of 3, 1 in polar coordinate system. Okay, so this is in rectangular coordinate system, and we want to represent this in the polar coordinate system. Okay, so we draw the distances. This is 1 unit, and this is square root of 3 units, or the distance from this point to this point is square root of 3, and this is your r. We first draw r. R is equal to the square root of the quantity negative square root of 3 square plus 1 square, and that is equal to 2. And then the angle theta is represented by arc tangent 1 over negative square root of 3. And since theta is located in between pi over 2 and pi, okay, theta is greater than pi over 2 but less than pi, and then theta is equal to 5 pi over 6, which means this point P negative square root of 3, 1 is represented by 2, 5 pi over 6 in polar coordinate system. Okay. Say we want to convert rectangular equation to polar equation or vice versa. So we will be using all these quantities derived earlier. Say we want to fill in this table. So we have x squared plus y squared equals 4 in rectangular equation. Then we want to draw its polar equation. Again, from this equation, r squared equals x squared plus y squared. We have x squared plus y squared here. So this x squared plus y squared can be replaced by r squared. So this circle with center at the origin, radius equal to 2 is represented by r squared equals 4 in polar equation. Okay, next we have r equals 3 sine theta in polar equation. We want to look for its rectangular equivalence. We first write r equals 3 sine theta, and then we know that sine theta is y over r, so we replace sine theta here. So that's r equals 3 times y over r, and then we multiply r both sides, so you have r squared equals 3y, and then again you replace r squared by x squared plus y squared. So finally we have 3y equals x squared plus y squared in rectangular. Again, r equals 3 sine theta is represented by 3y equals x squared plus y squared in rectangular equation. And this is a circle with center at 0, 3 halves, with radius equal to 3 halves. Next, y equals 2x plus 1 in rectangular. We want to draw its polar equivalence. Say y equals to x plus 1. From here, you know that cosine theta equals x over r, and sine theta equals y over r. Then r sine theta, that is our y, and equals 2. Then x is r cosine theta plus 1. And then we collect similar term. So you have r sine theta minus 2r cosine theta equals 1. And then by common monomial factor, we factor out r. So r sine theta, r times the quantity sine theta minus 2 cosine theta equals 1. And then finally, we look for r by dividing both sides of the equation by sine theta minus 2 cosine theta, and we have r equals 1 over sine theta minus 2 cosine theta. So which means the rectangular equivalence of y equals 2x plus 1 in polar equation is r equals 1 all over sine theta minus 2 cosine theta. Okay. And the most commonly typed of polar equations are, number 1, limaisons. And these are the characteristics in the general equation of a limaison. R equals a plus or minus b sine theta, where a, b element of real number, or r equals a plus or minus b cosine theta. And here are some examples. We have r equals 1 minus 2 sine theta, r equals 1 plus 2 cosine theta. Also, we have r equals 2 plus 2 sine theta, and r equals 1 plus cosine theta. And here are the characteristics. Okay, the behavior of the limaison is dependent on the values of a and b. If a is greater than 0 and b is greater than 0, and r equals a plus b sine theta is symmetric with respect to the pi over 2 axis and its extension and pointing upward. If it's pointing upward, then it's facing downward. So we have a plus b sine theta. pointing upward, and facing downward. Next, r equals a minus b sine theta is symmetric with respect to pi over 2 axis and its extension and pointing downward and facing upward. So this is an example of limason facing upward, pointing downward. For cosine, if that is positive, it's symmetric with respect to the polar axis or the line OX and pointing to the right. If positive, pointing to the right and facing to the left. So this is limason pointing to the right, facing to the left. If that is minus, if r equals a minus b cosine theta, symmetric with respect to the polar axis and pointing to the left, facing to the right. Minus, pointing to the left, facing to the right. And if a over b, if a over b is greater than 0 but less than 1, it's a limason with a loop. This is an example of limason with a loop. If a over b equals 1, meaning if a equal to b, then a special type of limason is observed. We call it cardioid or the heart-shaped limason. These are examples of cardioid. And if a over b is greater than 1 but less than 2, then the limason is called limason with a dent. And if a over b is greater than or equal to 2, then the limason is called convex limason. And then the second one is the rose petal or the n-leaf rose. So it's characterized by the equation r equals a cosine k theta and r equals a sine k theta. And the number of petals or the number of petals is determined by the value of k. If k is odd, then there will be k number of petals, and if k is even, there will be 2k number of petals. So these are examples. So this is a 3-petal curve, and this is an 8-petal. So where k is 3, so there are 3 petals. Where k is 4, so there are 4 times 2 petals, so there are 8 petals. And then we also have lemniscates. It's characterized by a spiral. They are spiral in nature, and its general equation is r squared equals a squared cosine 2 theta, and r squared equals a squared sine 2 theta. And here are some examples. This is a lemniscate defined by r squared equals 2 cosine 2 theta, and this is an example of lemniscate defined by r squared equals sine 2 theta. To trace polar equation, we identify several steps to make it easier to trace polar curve on the polar coordinate paper. The first step is to get the intercepts. The intercepts are the values of you look for the values of r for theta equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. And step number 2 is for the test for symmetry. Test the equation for its symmetry. So what are you going to do is to replace theta by negative theta. And if the equation is unchanged, then it is symmetric with respect to the polar axis or the line OX. Replace theta by pi minus theta. And if the equation is unchanged, after manipulating, after simplifying, then that is symmetric with respect to pi over 2 axis and its extension. And finally, you replace theta by pi plus theta, and if the equation is unchanged, then it is symmetric with respect to the pole or the origin. Okay. Then step number 3, you get additional points whenever necessary. If these two informations are not good enough to trace the polar equation, then you add additional points. And then finally, you smoothly trace the curve. Okay, so we want to trace r equals 3 cosine 2 theta. So r equals 3 cosine 2 theta is a petal curve, okay? And there will be 4 petals because the value of k is 2, so 2 times 2, that's 4. So this is a 4-leaf rose. Okay, step number 1, intercept. And then we supply the value of r for this table. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when theta is 0, cosine 2 times 0, that's 2 times 0 is 0. Cosine 0 is 1 times 3, therefore we have 3 here. Pi over 2. 2 times pi over 2, 2 times pi over 2 is pi. Cosine pi is negative 1 times 3, it's negative 3. Next, pi. 2 times pi, that's 2 pi, and cosine 2 pi is 1 times 3, then that is also equal to 3. Next, 3 pi over 2. 2 times 3 pi over 2 is 3 pi, and cosine 3 pi is negative 1 times 3, that's negative 3. And finally, you have 2 pi here. 2 times 2 pi, that's 4 pi. Cosine 4 pi is 1 times 3, that is 3. And then we want to trace these points on the polar coordinate paper. Say you have 3, 0. This is the point 3, 0. The next, negative 3 pi over 2. This is pi over 2, and then the radius vector is negative 3, so you trace it on the opposite angle. 1, 2, 3. So that's the point negative 3 pi over 2. And the next, 3 pi. So this is your angle pi. So you have 1, 2, 3. So that is your 3 pi. The next, negative 3, 3 pi over 2. So this is 3 pi over 2. The radius vector r is negative. So you trace it over here. So you have 1, 2, 3. Okay, that's your negative 3, 3 pi over 2. And finally, 3, 2 pi is the same point as 3, 0. Okay, and this is not sufficient enough to trace the four-leaf row. So we go on to step number 2, the test for symmetry. Okay, we first replace theta by negative theta. And then, so r equals 3 cosine 2 theta will become r equals 3 cosine 2 times negative theta. And then by the add even identity, cosine of negative x is cosine x. So we can now say that r equals 3 cosine negative 2 theta is the same as r equals 3 cosine 2 theta. So it go back to the original equation. Therefore, it is symmetric with respect to the polar axis, which means it is symmetric over this line. We replace theta by pi minus theta. So we have r equals 3 cosine 2 times pi minus theta. Simplifying this part, you'll have r equals 3 cosine 2 pi minus 2 theta. And then you use this identity, the sum and difference of the angles. So you have r equals 3 cosine 2 pi cosine 2 theta plus sine 2 pi sine 2 theta. And then we know that sine 2 pi is 0, cosine 2 pi is 1. So all this will become 0. So you only left with this. 1 times cosine 2 theta is cosine 2 theta times 3. That is 3 cosine 2 theta. So it goes back to the original given. Therefore, it is symmetric with respect to pi over 2 axis and its extension. Next, we replace theta by pi plus theta. So we do the same. R equals 3 cosine 2 times pi plus theta. So that will become r equals 3 cosine 2 pi plus 2 theta using the same identity. So you will have r equals 3 times the quantity cosine 2 pi cosine 2 theta minus sine 2 pi sine 2 theta. And again, sine 2 pi is 0, cosine 2 pi is 1. And what is left is r equals 3 cosine 2 theta. And therefore, this is symmetric with respect to the pole or the origin. And step number 3 is to add additional points. So those are the points pi over 6, pi over 4, and pi over 3. Okay, cosine 2 times pi over 6. We have 2 times pi over 6 is pi over 3, and cosine pi over 3 is 1/2 times 3, that's 3 halves. Next, 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0 times 3, that is 0. Then for pi over 3, 2 times pi over 3 is 2 pi over 3, and cosine 2 pi over 3 is, it's located somewhere here. This is in rectangular, this is negative x-axis. Okay, so you have 2 times pi over 3 is 2 pi over 3, and cosine 2 pi over 3 is negative 1/2 times 3, that's negative 3 halves. And then again, we set this point on the polar coordinate paper. So pi over 6, 3 halves. Or sorry, that's 3 halves pi over 6. So we locate pi over 6, and then we count from the origin, we count 3 halves unit. That's 1.5. 1.5. Okay, the next, pi over 4, 0. Pi over 4, 0. So it's located somewhere here. And the next, pi over 3, negative 3 halves. This is your pi over 3, and then the radius vector is negative, so you trace it on 4 pi over 3 axis. So we have 3 halves, 1.5. So then we're now ready to trace the curve. So you start at this point, and a curve will ascend going to pi over 6, and then it will go down at pi over 4. So you have this part of the petal. So we are now tracing the behavior of the curve as our last and final step. And then you will notice that for every multiples of pi over 4, for every multiples of pi over 4, the radius vector r is 0. So at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, all the radius vectors are 0. So which means from 5 pi over 4, 0, you can trace a curve going to 4 pi over 3, and then at 3 pi over 2. So another behavior of the curve is from this point going to this point and to this point. So you'll have that. And then we will now use this information. Again, the four leaf rows r equals 3 cosine 2 theta is symmetric with respect to the x-axis, or the polar axis, sorry, polar axis, or the line OX. So which means this part of the curve will have a reflection over here, and it will look like that. So we now have a complete petal. And then again, this part of the curve, since that is symmetric with respect to this line, so it will have a reflection on above this line. So we'll have that. And then finally, the polar equation is symmetric with respect to pi over 2 axis, or this line. So this two curve will have an image on the right side, and it will look like that. So we now have 1, 2, 3 petals, and for the fourth and final petal, that will be a reflection over here. So this curve will have a reflection over here. So, and that completes the four petal curve r equals 3 cosine 2 theta, and it will look like this. Okay, next, we want to sketch the cardioid defined by r equals 2 plus 2 sine theta. So again, a cardioid is a special type of limason where the value of a and b are equal. So we again intercept, and then we complete this table. Sine, so for when theta is 0, so sine 0 is 0, times 2 is 0, plus 2 is 2. Next, sine pi over 2. Sine pi over 2 is 1, times 2 is 2, plus 2 is 4. Next, sine pi. Sine pi is 0, times 2 is 0, plus 2 is 2. Next, sine 3 pi over 2. Sine 3 pi over 2 is negative 1, times 2 is negative 2, plus 2 is 0. Next, sine 2 pi. Sine 2 pi is 0, times 2 is 0, plus 2 is 2. And then we plot this point on the polar coordinate paper. For the first point, that's 2, 0. So this is the angle 0, and then from the pole, you count 2 units. 1, 2. Okay, next, 4 pi over 2. This is your angle pi over 2, and then from the origin, you count 4 units. 1, 2, 3, and 4. So this is your next point. Then 2 pi. So this is your angle pi, and then you count 2 units. So that's the fourth point. Next, 3 pi over 2. So this is 3 pi over 2, and then its point is located at the origin. Next, 2 pi is the same as 2, 0. And then we trace the symmetry. We test the symmetry. So we replace theta by negative theta. So we have r equals 2 plus 2 sine theta is the same as r equals 2 plus 2 sine negative theta. And then you use this identity. That's add even identity. Sine function is an add function. Therefore, sine of negative x is negative sine x. So we now have, if this is negative sine x, therefore that will become 2 minus 2 sine theta. So therefore, this cardioid is not symmetric with respect to the polar axis or the line OX. And then we replace theta by pi minus theta. And then again, we use this identity. So we'll have r equals 2 plus 2 sin cos cosine. That's the mnemonic device. Sine pi cosine theta minus cosine pi sine theta. And we know that cosine pi is negative 1 and sine pi is 0. So if this is 0, so this first term is 0, and this is negative 1 times negative, that will become positive. So this term will become positive sine theta times 2. So it will go back to the original given, r equals 2 plus 2 sine theta. So therefore, This cardioid is symmetric with respect to pi over 2 axis and its extension. Next, we replace theta by pi plus theta. So we have, doing the same, r equals 2 plus 2 sine pi plus theta. And then again, by sin cos cosine principle, r equals 2 plus 2 times the quantity sine pi cosine theta plus cosine pi sine theta. And then again, cosine pi is -1 and sine pi is 0. So again, this term will become 0 and this term will become negative. So we'll have r equals 2 minus 2 sine theta. And therefore, it did not go back to the original given. So that is not symmetric with respect to the pole. So the cardioid r equals 2 plus 2 sine theta is only symmetric with respect to the pi over 2 axis and its extension. By the way, based on the characteristics that we enumerated earlier, the cardioid r equals 2 plus 2 sine theta is a cardioid facing downward, pointing upward. So this is how your cardioid will look like. It's facing downward and pointing upward. Okay, so the next step is to add additional points and we complete this table. We look for the value of r whenever theta is pi over 6, pi over 4, and pi over 3. Okay, so if theta is pi over 6, you get r equals 2 plus 2 sine pi over 6. Sine pi over 6 is 1/2 times 2, that's 1, plus 2, that's 3. And the next, if theta is pi over 4, sine pi over 4 is the square root of 2 over 2 times 2, that's square root of 2, plus 2, that's 2 plus square root of 2. Square root of 2 is approximately 1.41, plus 2, this is equivalent to 3.41. And the next, if theta is pi over 3, so you have sine pi over 3, that's square root of 3 over 2, and then 2 times square root of 3 over 2 is square root of 3 plus 2, that's 2 plus square root of 3. And square root of 3 is approximately equal to 1.73. And then plus 2, that's 3.73. And then we now set these points on the polar coordinate paper. We have 3 pi over 6. So this is your pi over 6, and then you count 3 units from the origin. 1, 2, 3. So this is your 0.3 pi over 6. Next, pi over 4. So this is your 3.41 pi over 4. And finally, your 3.73 pi over 3. And then we trace this curve. You start at 0. It will ascend at pi over 6, going to pi over 4, to pi over 3, and pi over 2. And then you will have this part of the cardioid. Okay, that's the behavior of your curve. And again, since this is symmetric with respect to the pi over 2 axis or its extension, so that is symmetric with respect to this line, and we will make a reflection of this curve on the left side. So this will have a reflection on the left side, and it will look like that. So unfortunately, this is not the complete graph for r equals 2 plus 2 sine theta, because we all know that this is a cardioid and we are expecting a set of points over this angles. So we need to add additional points. So these are the table that we generated earlier, right? So we need to add points at 7 pi over 6, 5 pi over 4, and 4 pi over 3. So we will be adding points over this angle. Okay, sine 7 pi over 6. 7 pi over 6 is located here, so that's on the negative y-axis. So sine 7 pi over 6 is negative 1/2 times 2, that's negative 1, plus 2, that's 1. Again, sine 7 pi over 6 is negative 1/2 times 2, that's negative 1, plus 2, it's 1. Next, sine 5 pi over 4. 5 pi over 4 is located here. So sine 5 pi over 4 is negative square root of 2 over 2 times 2, that's negative square root of 2, plus 2. So you have got 2 minus square root of 2. And square root of 2 is 1.41. So 2 minus square root of 2 is approximately equal to 0.59. Next, sine 4 pi over 3. 4 pi over 3 is located somewhere here. So sine is still negative. Sine 4 pi over 3 is negative square root of 3 over 2. So times 2, that's negative square root of 3 plus 2. So you will have 2 minus square root of 3. And this is approximately equal to 0.27. So that's 2 minus 1.73. And then we set these points here. So we have this part of the curve. And since this is symmetric with respect to this line, you just show reflection over this angle. So, and that completes the cardioid r equals 2 plus 2 cosine theta. And it will look like this. Okay. All right, next. We sketch the lemniscate r squared equals 4 cosine 2 theta. Again, the lemniscate r squared equals 4 cosine 2 theta is spiral in nature. So again, for the intercepts, since this is r squared equals 4 cosine 2 theta, and what is represented on our polar coordinate paper are the values of r. So we need to look for the r here. So r equals 2 the square root of cosine 2 theta. So where if theta is 0, so cosine 2 times 0 is 0, cosine 0 is 1, the square root of 1 is 1, times 2, you have 2. Next, pi over 2. 2 times pi over 2 is pi. Cosine pi is negative 1. Square root of negative 1 do not exist. It's undefined. Times 2 that will still not exist. So we represent it by infinity. Next, pi. 2 times pi is 2 pi. Cosine 2 pi is 1. And square root of 1 is 1. Times 2, we still have 2. And for every multiples of pi over 2, the value of your r will not exist. So we have that. And then finally for 2 pi, it will, since 0 and 2 pi terminates on the same angle, and then the value are similar. And then we set these points. So we have 2, 0. So this is the angle 0. And then from the pole, you count 2 units. 1, 2. So this is the point 2, 0. And then we cannot trace this on the polar coordinate paper since the value of r do not exist. And then we proceed with pi, 2 pi. So from 0, this is your angle pi. And then you count 2 units. 1, 2. That's your point 2 pi. And then again, this cannot be plotted on the polar coordinate paper since the value of r do not exist. And then 2 pi is the same as this point. Okay, then for the test for symmetry, we replace theta by negative theta. And then, following the same procedure, so again, cosine negative x is cosine x, so r squared equals 4 cosine 2 theta. So the lemniscate r squared equals 4 cosine 2 theta is symmetric with respect to the polar axis or the line OX. And then we replace theta by pi minus theta. So we have r squared equals 4 cosine 2 times pi minus theta. And it will look like this, okay? R squared equals 4 times the quantity cosine 2 pi, cosine 2 theta, plus sine 2 pi, sine 2 theta. And we know that sine 2 pi is 0, cosine 2 pi is 1. So 1 times cosine 2 theta is cosine 2 theta times 4. So you have 4 cosine 2 theta. And it go back to the original given. Therefore, it's symmetric with respect to pi over 2 axis and its extension. And finally, we replace theta by pi plus theta. So you're doing the same. So you will notice that it will go back to the original given, r squared equals 4 cosine 2 theta. And therefore, the lemniscate r squared equals 4 cosine 2 theta is also symmetric with respect to the pole or the origin. Okay, and the next step is to add additional points. So we look for the value of r whenever theta is pi over 6, pi over 4, and pi over 3. So we have r equals to the square root of cosine 2 theta. If theta is pi over 6, 2 times pi over 6 is pi over 3, and cosine pi over 3 is 1 half. And square root of 1 half is the square root of 2 over 2 times 2. So the value of r is square root of 2. Next, 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0. Square root of 0 is 0 times 2 is still 0. Next, cosine 2 times pi over 3. So you got cosine 2 pi over 3. And since 2 pi over 3 is located between the angles pi over 2 and pi, therefore, the values of the cosine function on that particular angles are negative, and the square root of a negative number do not exist. So therefore, at pi over 3, at any multiples of pi over 3, r will be undefined. You can use your calculator to verify these values. And then we trace the points. So you only have square root of 2 pi over 6. Square root of 2 is approximately 1.41. So this is your 1.4, some approximately equal to 1.41. And pi over 4, 0. So this is pi over 4 and 0. And then we can now trace our lemniscate. And then from 0, then you go at pi over 6, and then you go down to the pole of pi over 4. So it will look like this. Okay, so we are now tracing the behavior of the curve. Again, that is symmetric with respect to the pi over 2 axis. So it will have a reflection here. And it also symmetric with respect to the polar axis or the line OX. So it will have a reflection here, or and that completes our lemniscate r squared equals 4 cosine 2 theta. So we will reflect this curve over this line. So it will look like this. And then since that is symmetric with respect to the line pi over 2, and this will have an image on the left side. And finally, that completes the lemniscates r squared equals 4 cosine 2 theta. So that's it for now. And the next part of this video is how to compute the area of region bounded by polar equations.